All right, let's get started. I welcome you all for this AI training program and really happy that you have shown interest and keeping faith in me, especially to those people who are associated with me from a long time, and also the new people who took an chance that let's see what happens. This is the outline came that some training is going to happen related to AI, and let's check out that how much we can gain knowledge from this particular training program. So let me assure you that we do have many things to do. As I already told, that I'm going to discuss from the basic till the advanced level in a flow covering most of the topics, but my concern will be related to the concepts, related to the maths, related to the algorithm model, related to the coding part, and obviously research and the development. Okay, fine. So you are seeing on the screen a template showing aims and the objectives, and there is nothing for me to read here. Okay, whatever I said, that is enough. Rest, whatever been mentioned here, you can read from your side. Okay, got it. Fine. Now let's proceed with our topic. I'm sharing my task screen. I hope it's visible to everyone. In case you find any difficulty related to the audio or video, please ping me. Okay. And if you do have any doubts, so like you can unmute yourself and you can ask. Not an issue. There is no like any kind of foundations. Fine. Artificial intelligence. Well, you guys all know about it. AI and
Sir, before we start, sorry to interrupt. Before we start, I just want to know whether this training is being recorded
yes,
by any
yes,
chance.
yes, yes. Recording has been started.
Okay, okay, sir. Thank you.
So, like artificial intelligence, you call that we are going to make a machine intelligent, or we are going to make a mimic of humans. Okay, that means we are interested that machine should also have a same intelligence as humans do have, or maybe we are trying to achieve artificial general intelligence. That means much more than that. Anyways, that's a later concern. Machine learning, deep learning, generative AI are the subsets. Like ML is the subset of AI, DL is a subset of ML, and generative AI is a subset of deep learning. Okay, what happens here, sir? We know, like we do have the algorithms. We apply the algorithms over the data. Machine learning, we give data to an model, or let's say an algorithm or a technique which can identify patterns in it and give the prediction. Okay, so machine learning is a subset of AI where we try to find, or we find patterns in the data, hidden patterns in the data. using an algorithm or a technique or a model which is statistical in nature. Statistical model, statistics based. Okay. Deep learning is again, we are going to find patterns in the data. In machine learning also we are finding the patterns in the data. In deep learning also we are finding the patterns in the data, but the difference is, in deep learning we are going to find complex patterns in the data. Okay, because machine learning is not enough to handle the data if its volume gets on increasing. Finding the pattern will be challenging. So again, the deep learning will be like data giving to artificial neural network. Then we are going to have the prediction. So artificial neural network is a network of neurons where they are organized over the layers. You have seen this thing. Okay. So we do have the layers, we do have the neurons organized over it, they are interconnected with each other. Okay, and we make a deep network. Okay, we make a deep network based upon it. All right, fine. So ultimately, we are going to find complex patterns here, which ML can't find. Okay, these things were happening. Then came generative AI, because the researchers, the scientists, the authors, they found, if we do have a lot of data, can't we use that data for generating the data again? So, like model, if we design in such a way that it can generate the data again, this is what, if it is possible, it's good thing. Okay, because we are available with huge amount of data, and and in form of text, in form of images, in form of audio, in form of video. So is there any algorithm, is there any technique which can be useful to generate the data again? So you know what happened? What kind of architectures? Because from deep learning, we learned to design the architectures. We learned to build the layers. We learned to build the maths from deep learning in terms of this neural network side. Okay, machine learning, these are the basic foundation statistical, mathematical, simple models. Okay, but when we move ahead towards the deep learning, we started organizing the layers, neurons, interconnections, complexity, all these things happen. Architecture development happens. And once we get a knowledge idea about these architectures and everything, then we proceeded ahead. Okay, and then we have decided to create a architecture which can generate the data also. Therefore, in this case, we do have encoder, decoder kind of architecture, or the successful ones are transformer. Okay, the transformer are built from encoder decoder only. So the idea is to compress the data, and to decompress the data. Okay, compression and decompression, this is how you can generate. Okay, so that's a transformer architecture or encoder decoder. There are so many other architectures also for the generation. We'll see. Okay, got it. So these things were going on. These things were happening. Afterwards, like what happened, sir? There are different types of learning techniques like we have heard about supervised learning, we have heard about unsupervised learning. Okay, supervised means we do have data in which labels are present. That means target is already there. Data with a target. Okay, so like when we were going to initiate anything related to data science, related to data analyst, related to machine learning, we start with like a data set given in this format. Very easy in this format. Sir, there is a CSV file, there is a Excel file, or whatever you will say, and here x1, x2, x3, x4, and let's say here the target. All right. So we do have the columns or the features. Okay, and we do have the entries present in these columns. All right, such kind of data. So, like if you are having a target, this is the target. Okay, then it's supervised learning, and we do have the algorithms for supervised learning. You know about it. So, linear regression, logistic regression, that is for classification. Okay, linear regression is for regression. Then, sir, support vector machine, regression classification both. Then, sir, decision tree, regression classification both. Random forest, XGBoost. Okay, there are so many algorithms. Okay. In unsupervised, we don't have the label, we don't have the target. We need to find the label. Okay, we need to find the label. That is why we do clustering here. Clustering, association, such kind of algorithms are present in unsupervised. Okay, at the concept says to find the like relationship between the data points. That is what we do. Okay, in unsupervised. We do have semi-supervised learning also. That means half part is supervised and half part is unsupervised. Okay, some of the data is labeled, some of the data is not labeled. So if we combine like such kind of learning over the data, it's called as semi-supervised learning. Okay, we do have reinforcement learning also. Reinforcement where we learn from the environment. Okay, and then take the decision. That's what we do in reinforcement learning. All right. So we do have let's say sensors. Okay, which take the action. Okay, and if the action is correct, then we are going to get the reward. If the action is incorrect, then we are going to get the penalty. So this is how the system works. This is how the system learns. Okay, so the sensors, they keep on checking or monitoring the activities. There is an algorithm, there is a technique, obviously, which takes a decision based upon the activity. If the decision taken is correct, you're going to get a reward. That means the model is working fine. Else, you are going to get a penalty. You take a wrong step. Okay, for example, a driverless car. I used to say many of the times this example of a driverless car. Okay, and reinforcement learning is one of the important technique used in large language models also, where we give make a model that whether correct outcomes or the results given by it or not, and like with this reinforcement learning, with this kind of technique, the model becomes much more better by thinking, by reasoning. The ability got increases. All right, so again, it's a very important topic, we'll see ahead. All right, then there is one more learning paradigm, that is self supervised. Okay, self supervised learning. In case if it happens that the model is trained on a particular data, and the model is not in knowing if any kind of data which comes in front of it, and model don't know about it. that what exactly it is, but it needs to do the prediction. So what model do is model learn new things. Okay, model learn new things from its own side. Okay, here you are not the person. Okay, so model learn new things. It try to accumulate that what came. Let me check, let me verify what is available with me. Okay, so that is self supervision. Okay, model do train or update its knowledge based upon the new data which came in front of it for the prediction. That is self supervision. Okay, got it. So here are some learning paradigms which I want to have a quick recap for you all, and you should remember. All right. So, you have regression, the task which we perform in general AI, machine learning. Regression, that means the target is continuous in nature. The target is continuous in nature. Classification, the target is categorical in nature. Okay, we perform segmentation also. Segmentation is to divide. Okay, we are going to divide the data, divide the image. Especially this segmentation is used for images part. So divide the image into segments. Okay, and this can be done on the basis of pixels, because pixels are the picture elements and image is made up of pixels. Okay, so we are going to divide the image on the basis of pixels. Okay. Also, we are going to further in segmentation. We can classify that if if because segmentation is having categories like semantic segmentation, instance segmentation. Okay, so if we are just only focusing upon the pixels of a particular object, doesn't matter how many kind of those objects are present, then it will be called as a semantic segmentation. For example, in an image, if you are having apples, 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 all three are apples only. So like we are just focusing upon the pixels that okay, these are the apples. Okay, got it. Fine. Then, if we further classify, this is Apple 1, this is Apple 2, this is Apple 3, then this is instance segmentation. That means we are not only identifying the pixel of a particular object, particular entity, but we are also classifying that these are different entities. Doesn't matter, it belongs to a same class. That is instance segmentation. So the tasks: regression, classification, segmentation, object detection. That is also one of the tasks. Okay, object detection. Fine. In an image, you need to identify that this is a person, this is a car or truck. You need to identify. So there are algorithms, advanced algorithms. People are researching on those algorithms. You can see the papers. You have heard the names. YOLO, you only look once. You've heard those algorithm names. Okay, YOLO 8, YOLO 9, YOLO 10, YOLO 11, YOLO 12, YOLO 26. Object detection algorithms. Okay, where we make bounding boxes on the objects which are present in the images. Also in videos we detect. Video detection is also as one of the concern here in object detection. All right, got it. After object detection, well, it depends what more tasks you are interested in, sir. We are looking in cyber fraud. That means finance domain. You can do use AI. Healthcare healthcare you can use AI. Okay, so there are so many. ETC, I'm going to write ETC. Education, so many options available where you can apply artificial intelligence and try to automate the system and make it free from human in a loop. That is what you want to do. That's what you perform. All right. Right now, there's a trend of AI agents because in this training, I'm going to talk about the AI agents, but it will take some time for me to cover or to reach this particular topic. So, what the people are doing, sir? Let's use the API key. Let's use the API key of Gemini or Chat GPT or whatsoever. What we'll do is, sir, we will make the front end, sir. Okay, we will make the front end, sir. All right, and besides, sir, we'll use the API key, sir. That is what we can do. So if a user is going to give any query, okay, this API will work and it will generate the outcomes that will be reflected or shown here in the front for you. Okay, so we in so many cases are using such, because right now it's been more in applications, AI agent building using API, MCP server, and etc. etc. There's so many terminologies available at the moment. Okay, but the point is what you are going to learn here. The thing which left with you is configuration. Sir, LLM is available. API, if you purchase, give the money, purchase. Okay, if you know to design some front end from your side as per your purpose, okay, therefore use all the techniques, skills related to the development part, and that's it. Okay, that's it. But the point is, if I talk about R&D, it doesn't hits the target or the goal. Still, there are many issues. Still, there are many issues. Okay, like AI is still maths. Still maths. What kind of maths? What topics? Linear algebra, statistics, probability, information theory, calculus, graph theory, all these things. Where linear algebra, statistics, these and calculus, these keys major portion. So if you are good in maths, if you are good in solving such equations, then you can make up with the AI. Some intellectuals, they said that no, still you haven't reached anything like in the AI because you're talking about a generation or you're talking about any AI model. It's mathematical formula only. You did converted it into the coding part next. Still, it is mathematical only. What kind of intelligence you are talking about? The point is what we have reached so far is we gave on the basis of algorithms reasoning ability. Okay, this strength we have give to the LLMs. Then generation, obviously it is doing. If we give any prompt, it give the desired result. Though there is a hallucinations, LLMs do hallucinate. Okay, hallucinations are there. It may give wrong results. It may give wrong outputs. For that, we do have the solutions. Like we use RAGs, retrieval augmented generation. Okay, I will also talk about these things ahead. So, these are all having mathematical background. The core thing which is working is the maths beside. Later on, you have developed the algorithm. Later on, you have converted into code, and there are separate files to solve a particular problem. Like for example, if I do talk about the Claude, so Claude do have the skill set, and with the help of skills it do solve a particular problem which you give in the form of a prompt. Okay, so like this is how you can can work on the AI. But but still R&D is something which is important, required. Though we are using the LLMs, doesn't mean that you can make a language model which can generate from your side in a easy way. No, no, not at all. It's not an easy for you. What it requires, resources, huge amount of data. You should have a knowledge about transformer architectures. You should have a knowledge about these things. What are transformers? What are every step which a transformer do? Okay, so before anything related to data science, related to data analyst, related to machine learning, deep learning, generative data, the one thing which is important here is the data. If you understand the data well, then you can proceed ahead slowly. You will get the idea of the architectures. You will get the idea of what is the working beside of those architectures. Okay, but first data. Okay, data, structured, unstructured. Two types of data. One is structured data, then unstructured data. Structured data means the one which is easy. Sir, table format. That is structured data on which you have worked many of the times. That's easy. Unstructured data, text, image, audio, video, unstructured data. These are. Now, this is challenging. If you are working on unstructured, then this is challenging. And we require specialized algorithms to work over it. Okay, so like if you talk about the machine learning algorithms, they are well in structured data. But if we talk about ML to work on unstructured data, then no, I think that is not something which is suggested. Then you have to push yourself towards the deep learning part. Anyways, in structured data, you do have the two categories further: numerical and non numerical. Okay, structured is divided into numerical and non numerical. Numerical is further divided into discrete and continuous. Discrete means countable, numbers which are countable, 1, 2, 3, 4, 5. Continuous, which are not countable, which we have to represent in class intervals. Okay, for example, 1.5, 2.7, 3.9, 4.6, such kind of numbers that are continuous in nature. Non-numerical are categorical and non-categorical. Okay, categorical obviously classes. Further divided into ordinal and nominal. So if we do have a category and they represent an order, then it is ordinal kind of data. And if you do have a category but they don't represent any order, then it's a nominal data. Okay, got it. So ordinal data, let's say we do have the grades: A grade, B grade, C grade, D grade, E grade, and the F grade. So if we do have the grades, then it's ordinal data. Okay, nominal means, let's say we are having colors: red, green, blue. So any of the positions can be taken by any of the color. We are having three colors. Any of the position can be taken. All right. So this is nominal data. So when we see the data, we should be knowing what type it is, what kind of entries are present in the data, and how to approach such kind of data. This is very, very much important. Not only for tabular, it is important for you to check out in text also, for you to check out in images also, for you to check out in audio also, and video also. Well, videos obviously are the frames which are at the end images only, so we don't process the video, we process the frames. Okay, fine. So we call these all as a multimodality. And right now, many of the research is working on multimodality. Okay, got it. You know the steps. Okay, once you are having a data, you know the steps. That, sir, first of all, we do the pre-processing of the data. Okay, we do all the refinements, cleaning of the data because you get the raw data. Okay, we do the pre-processing, and every kind of data has its own pre-processing technique. If you are working with the text, then its pre-processing requires removal of the stop word, removal of the punctuation, removal of the digits, removal of any special character. All these comes under pre-processing of text. If you talk of images in pre-processing, then you need to resize the image, you need to change the color of the image, you need to normalize the pixel values. So such kind of pre-processing is required in the images part. In audio also, you need to filter the audio, remove the noise. Okay, frequency, bandwidth, amplitude, etc, etc. So whatever be the kind of data, you need to apply the pre-processing to clean the data. That is very important. First of all, okay, some are associated steps related to it. EDA, exploratory data analysis, explore your data, do the visuals, visualization, make the plots. Then there is feature engineering, where you create new features from the existing data. That is called as feature engineering. Okay, you also filter the data. That means look for only the columns or the features which are important, because next you are going to do the model part. That is modeling. You are going to put the data into the model. Okay, you split the data. Okay, training, testing, validation. All right, training, testing, validation. You split the data into three. Okay, let's say 80% training, 10% testing, and 10% validation. You divide the data and give it to the model. Okay, so there's a training performed. There is a training performed at the model end. Okay, you know about it. I will discuss about it. What training we do. Okay, so modeling done. Then after model, testing is performed, and then if everything is fine, then deploy the model. Then deployment has been done, and later on there's a complete circle like CI/CD pipelines. Okay, this performance is continuously monitored. That model is working good or not. So this is called a CI/CD pipelines. Okay, got it. So these are the steps which is being taken into consideration while doing from the zero. Okay, data collection till the deployment, and after post deployment also there is a check that the working is good or not. All right. Now now since I mentioned all these steps, I talked about the data. Training training what do you do in training? Whose training is performed here? Well, we know the equation, which is very, very popular. Y equal to mx plus b. This equation is a very popular equation. Sir, linear equation. Linear equation. Very popular. It's very like simple, sir. We have seen in our school also, in machine learning also, in deep learning also, everywhere this equation has been present. What is the reason? The reason is this equation generalizes the model results. Obviously, it is easy for interpretation. Okay, it's easy for interpretation because our goal is to make a general model, generalized model. Okay, and what is present in this equation? What is present? Output is there. Y. Input is there. X. M and B are there. Parameters. These are parameters. So, what is training? What is training? Training is adjustment of parameter only. Okay, because we do have the input, we have the desired output. Let's say. So we need to tune the parameters. We need to adjust the parameters so that once the parameter get adjusted, next time if we give the value of x, they can predict a y. Okay, fine. So this M and B are very fine written Wx plus B. Weight, bias. Weight, weight in terms of neural network means strength of interconnection between two neurons. Bias means error. Okay. So weight decide that how these two neurons are interconnected and how much amount of information should flow from one neuron to the another neuron. This is decided by the weight. And not only in neural network, in linear regression, I am talking about this linear regression equation only. This line equation linear only. Okay. Later on, like this thing applicable to neurons, but we started with linear regression like this only. Okay, got it. So like parameters, W and B. So training of parameters happens. Got it. And like how how this training is being made successful. Let me talk about linear regression, or let's say regression. How this is made successful. You know what happens in machine learning? Y equal to Wx plus B, you know. Yp is the prediction. This is the prediction. Okay. Yp minus y is error. So these things are not new, sir. Sir, this is linear equation. We have an idea, and the model gives a prediction. That is also an output. Y is also output. Y is also output. Yp is also output. And our goal is if we give data to a model, then data over a model should give a correct output. That is what we desire. That is what our expectation is, isn't it? So model will not give in a one time. If you apply a good result, it will take some time. It requires training. Training means we are going to tune these parameters, adjustments. Then only it will give the correct results. So first it will give the error. And our goal is to reduce the error. So what is error? Yp minus y equal to error. Alright, let me write again. Error is equal to yp minus mx plus b. Okay, because value of y is mx plus b. Now, since we have learned in calculus, differential calculus, what is your goal? To reduce the error. That means you want to achieve minima. You are here, you want to reach here, you want to set a goal where error is minimum. So, what we do? Differentiate. We differentiate the equation. But differentiation will be successful when you are having higher order term. So we never differentiate like this equation which you are seeing in right now in front, yp minus y. No, no, this is not differentiation. What we are going to do is we are going to square it. Yp minus mx plus b ka whole square. We need to differentiate higher order term, not lower term or one order. No. Okay. So do the square. After squaring, take the average of all the errors. So this is error. This is square error divided by is mean square error. Take the summation. This will be MSC, mean square error. This is the equation which we need to optimize, which we do optimize in regression. Mean square error. All right, got it. However, there are certain issues. Okay, my lecture is context to interview also. Okay, so you do not have to prepare anything. Just listen to me for this 1 month. You are being ready for the interviews also. Now, as I told that we need to make a general model, generalized model. Right now, you have seen that I have gave one equation, an error equation I have given to you. Okay, we need to make a general model. General model means there are two things on this side of general model. One is on the left, one is on the right. These are these are underfitting and overfitting, and this is general. The two things. Underfitting means, sir, model during training also performing poor. If training is poor, then how testing will be good? Testing also poor. That means model is unable to understand the patterns in the data. Poor. I am asking something else and model is giving something else. Fail. This is failed model. Underfitting. Overfitting, sir. During training, sir, model is giving good response, sir. High accuracy, sir. But during testing, model fail. Low accuracy. That means model memorized the pattern. Memorization. Model memorized what you gave as an input. Model didn't learn the patterns. So, like this, we call as complex. Model become complex. Here, model is easy, but I don't want to make neither complex, neither easy. I want to make a general model, generalized model, where there will not be any overfitting, there will not be any underfitting, and like that's why when you make any research paper, whenever you build any algorithm, or you have seen the research papers, you have seen the results present in the research paper, you might look for, sir, the accuracy of the model given in the research paper is 99.76%. How the hell they got 99.76% accuracy? No, no, this is not justified. This is not justified. Well, according to me, if accuracy is 96 and 97 around, it's good. If we achieve 98, at least I should keep 2 to 3% of scope, where I will say that might be I am wrong, because this is artificial intelligence. Human can make a mistake. How machine can give 100% correct answer? How this is possible? Got it. Okay, so like keep some space. 99%, 100% not justified. Okay, got it. So whenever you are doing a research, you are writing in the articles, you're developing a model, you are comparing the model. what you need to do is, what you need to focus is, okay, you need to achieve the scores, but still check and claim. Accuracy is not everything. Computational complexity is also important. Computational complexity is also important. That means how much time the algorithm took on machine to run or to produce the output. So computational complexity. Okay, scores, accuracy it is giving 97%, but it is taking less time to give that particular score. We achieved that as a part of our research. We build some kind of a maths. We build some kind of an layer. We build some kind of an architecture which is giving a score this much, less computational complexity, memory, hardware requirements are less. That's what the research is. Okay, got it. So I talked about the equation related to the regression and some overfitting, underfitting part, general model we are expected to make. Okay, we do have the classification also. Okay, we do have a classification also. Classification. Okay, let me make a separation. A and B. A and B. Okay. Um, P and Q. P and Q. Let's say P and Q. This is actual and this is predicted. Actual and predicted. Okay. We are having apple. We are having peach. In actual, apple is 1, peach is 0. And the model predicted it as apple as 0.8, peach 0.2. These are probability. Okay, model gives probability, probabilistic results. Okay, because there is uncertainty, there might be a question in the interview, or either it may be asked to you in general context, that model uses probability, like isn't model confirmed? The model, it's uncertain, na? There is uncertainty in the data, there is uncertainty in the outcome. Okay, that is why probability came into the picture and probability works here. Okay, that's why the model is using the functions, probabilistic functions. Like if you know Shortmax activation function, Shortmax. Okay, and the Shortmax activation function is used where you are performing multi-classification. The formula for Shortmax is e key power x upon summation of e key power x. All right, got it. So it gives the probability of each and every outcome. And if you are doing binary classification, then we are having sigmoid. Okay, sigmoid. The formula for sigmoid is 1 upon 1 plus e key power minus x. And here is the figure for sigmoid between 0 to 1. Okay, this is zero point 0.5 threshold. Okay, got it. So probability, because model is uncertain, uncertainty is there in the outcome. That is why model uses probability to give the outputs. That's one of the reasoning question answer. Okay, got it. So what is the current scene now? In actual, you are having apple. You don't have a peach. But the model is giving 80% chance that this is an apple and 20% chance that this is a peach. Okay, got it. So we use this probability and information theory concepts. Like for uncertainty, we do have entropy. That is minus summation of p log p, where p is the probability. So for uncertainty, we do have the entropy, and p is the probability. But this is for one distribution where you do have only p. But right now we are having q also. Okay, so we use cross entropy. We use cross entropy. That is minus summation of p log q. This is cross entropy. Okay, got it. So therefore, you have minus, in actual apple is 1, predicted it is zero point 0.8, In actual, we don't have a peach. In prediction, we do have point 0.2. This is how you will calculate the cross and draw. Okay. Generalized formula minus p log q minus 1 minus p log of 1 minus q. This is the generalized formula. And as I gave you the equation of regression, similarly, this is the equation for classification, that is cross entropy or loss. This is the loss equation. And we need to optimize. So we need to optimize that regression also. We need to optimize this classification equation also. What is optimization? What is optimization? Optimization, you need to differentiate it. And you need to find the optimal value of parameters. That where the loss will come minimum. That is what you need to do. It is again weight and the bias. So in this P and Q, there will be weight and the bias present, and then there will be differentiation with respect to weight and the bias. Okay, like this: delta y by delta w, delta y by delta v. This is what happens. We do the partial differentiation for optimization. Okay, and this is being followed in back propagation of neural network. Okay, got it. Fine. Therefore, therefore, I do have some mathematical questions for you. Here is a mathematical questions, because it is mandatory for you all to go through the maths, because I'm going to make you alert that focus on such foundations, some such concepts, along with some reasoning, along with some coding, along with the research and development part. All right, so we do have real numbers. -1 should not be there, and there is a operation mentioned like a star b equal to ab plus a plus b, where a and b are the real numbers which don't have -1 as a value, and we need to prove that this is an abelian group. Abelian group. So what is abelian group? Abelian group is a group which follow closure property, associative property, identity property, and inverse property, at the last commutative property. So if your this equation follows all these property, okay, then it will be an abelian group. Fine, that's what done here. Like for closure a and b should not equal to -1 as mentioned. So we do have a operation b is equal to this. We took a common from here, then b also common we took, and reorganize it in this way. Okay, reorganize in this way. A plus 1 should not be equal to 0, because a is not equal to 1, neither b is equal to 1. So obviously the inequality holds. So this is also not equal to 0, obviously. If they are not equal to 0, then multiplication also be not equal to 0. If individual is not equal, then how the multiplication is going to be equal to 0? Okay, so this is also not equal to -1. Okay, suppose a operation b is -1, let's say, then this is equal to -1. This is equal to 0. Okay, this is impossible. This is impossible because according to the condition mentioned now, we are not going to do any step which doesn't satisfy. So following up that a and b are not equal to -1, we got that that this operation is closure in nature. Associative. Associative. What is associative property? Obviously, A operation B, then operation C is A operation B operation C. That means brackets. First apply on A and B, then apply, then this equal to B and C operation. Okay, if you do some hands on, if you do some hands on, you'll get an idea. You will get an idea. A operation B value you already know. Okay, whatever the result you got, apply it on C. Keep it. Then A operation, B operation, C. So B operation C you do. How what did you give the result? What it will give the result? It will give like this. It will give like this. BC plus B plus C like this. All right. So you need to put an A is in operation again. Fine. So here the entire calculations, required calculation followed, performed. Okay, A operation B operation C is equal to A operation B C plus A operation B plus C. Okay, it followed the general equation which is mentioned here. It followed the general equation which is mentioned. And if you keep on elaborating both left hand side, right hand side, you will get your desired answer. All right. So this is associative in nature. Identity element E. Okay, identity, like if we are doing plus, so identity is zero. If you are doing multiplication, then identity is one, like this. Okay, it's mentioned here. Inverse, like this. A operation A inverse is equal to zero. Again, formula is given to you. If you apply like this, okay, you will achieve those. Commutative A operation B is equal to B operation A. So this is the basic question of maths which we do in set theory or like in group concept, group theory. Okay, and I took from that in front of you. So at least you should remember what are the identities which we solve in linear algebra. Okay, got it. We perform matrix multiplications also. Very important, because your data is organized in this way. Easiest way to organize the data is matrix format, row column format, table format. And first is the point representation. Sir, this is easy, sir. Point representation. Then, sir, vector representation, sir. Mark vector. Okay, so vectors and matrices, where to represent the data, where to organize the data. Here the question is matrix multiplication. So there is a property to multiply matrix. This is 3 cross 3 matrix. This is 3 cross 3 matrix. If this and this are equal, then only you can multiply the matrix. Else you cannot multiply the matrix. So if this is 3 and 3, you can multiply the matrix. Same thing here also. Okay, check for this one. 2 row 4 column, so 2 cross 4, this is 4 row and 2 column, 4 cross 2, these two are equal. Yes, you can multiply also this also. Check for here also. 4 row 2 column, this is 2 row 4 column. Okay, multiplication possible. Got it. So just check the order, then multiplication you can do. Okay, I hope you can make a multiplication and the result will be 4 cross 4, remember. Okay, the output matrix will be 4 cross 4. Got it? Okay, so this is what you should be able to perform multiplication also. Very important. Fine. Okay, here are the solutions that you can refer. I will share all the documents for you to see the mathematical calculations, formulas. I have notes also, that too I will share. We do have subspaces also, which contain zero vector and be closed under addition and scalar multiplication. So we do have subspaces. For example, this is a vector v. We can have lambda v also. So for example, you have a v vector, then 3v vector. That means three times than the existing vector. We call it as subspaces. So here are some questions which are which are asked to find that whether the following set are subspaces or not. Well, lambda is a scalar quantity. Okay, got it. Solutions you will get to know from here by assigning lambda 0, mu 0 in a vector format, putting those values into the existing set, and just checking whether satisfied or not satisfied. By that you will get the results of subspaces. Okay, all right. Some metric solution also has been there. System of linear equations are there. Unique solution, infinitely many solution, no solution, consistent solution. I hope you have seen in engineering maths that has also been present here. Okay, so you may get a matrix where you have to find whether this is giving a solution or no solution, or infinite solution, consistent, inconsistent, whatsoever. Okay, multiple equations which can be represented in a matrix format. Like if you have 2x plus 3y plus 4z equal to 10, 5x plus 3y plus 7z equal to 15, and so on. Put all those things here. This is x, this is y, this is z, this is the output which you are getting 10, 11, 12. Make an augmented matrix and solve it, and see whether value of x, y, z are coming or not. Got it. So this is one of the mathematical problem solving I will share with you along with the notes. Today only I will share. You need to go through these questions. Next, I have reasoning questions. Reasoning. Okay. You have a data set, car with column brand, fuel type, horsepower, price. Some are numeric, some are non-numeric. What you are going to do with them? Brand, fuel type. You have to understand. Okay, brand like Toyota, BMW. In this way, what can we do with such kind of data? One hot encoding. That means creating dummy. Why? See, if you do have a data, let's say brand here, as per the question, Toyota, BMW, Ferrari, or whatever. So, all these things are different brands. They keep their own importance. So, if you want to convert this into numerics, now you need to do one hot encoding or creating a dummy. Therefore, separate columns will be created. Brand Toyota, brand BMW, brand Ferrari. Wherever brand Toyota is there, Ferrari and BMW will be zero. Whenever BMW will be there, Toyota and Ferrari will be zero. Wherever Toyota and BMW zero, Ferrari is there, it's one. This is one hot encoding. However, if you are having data, petrol, diesel, electric, there is a natural ordering. In order, you don't do one hot encoding. Remember, you can. mark them as, you can mark them as 1 2 3, or label encode them. Okay, label encode. So petrol is 1, diesel is 2, and electric is 3. This is what you can do. Remember, if there is an order, if there is a label, then don't do one hot encoding, don't create the dummy, label them. This is what you can do. So 1 2 3, like this. That's a question which I am answering. It's a reasoning question. You are building a system to predict the remaining useful life of an aircraft engine. What you choose, a deterministic function or a probabilistic model? You are going to build a system to predict the useful life, remaining useful life. So the kind of a model will be deterministic or it is probabilistic. See, probabilistic on the basis of safety concerns and noise. You are looking to identify, to predict remaining useful life of engine. Maybe engine work, maybe engine fail. That's probability. We are not determining there. There's no determination. There's a probability. Either engine will work, either engine will fail. What's the chance? Okay, this much lifetime is left. What is the chance that it will work? So, uncertainty, knowing the uncertainty, 90% of the confidence or whatever, uncertainty is there. Okay, engine degradation, other things are there. So, you are going to make a probabilistic model, not a deterministic model. Got it. Fine. All right, all right, all right. Empirical risk maximization, will minimization, we'll see ahead. Okay, maximum likelihood. Okay, again, a statistical kind of questions are there. Okay, okay. You are going to train a linear regression model with 50 housing examples with 200 features, including irrelevant ones. See, number of features we need to limit. Okay, 200 features, most of them are irrelevant. Obviously, they will be irrelevant. There is a problem in machine learning that is called as curse of dimensionality. There might be features which are irrelevant, there might be features which are dependent upon each other. At the end, they are going to overfit the model. All right, so take care. Only important features which are contributing to the target, those features should be kept, and which are least related among each other, such features should be kept. The training error is zero, testing error is huge. Obviously, overfitted model. What you are going to ask? It's an overfitted. So, if a model is overfitted, what you need to apply? Regularization, cross validation. Regularization is a penalty. If a model is overfitted, penalize. Penalty should be given to the model. And to whom you are going to penalize? Parameters. You are going to penalize parameter, because what is learning? Parameter. So penalty will be given to the parameter. Got it. Understood. So this is one of the question. And above questions, maximum likelihood estimation, empirical risk minimization. One more question has been present here. Probabilistic model for regression, mean, variance. I'm going to talk ahead about them because it requires some statistical details to go through. Like this is our preferred distribution of data, Gaussian or normal. This is preferred. So if you're learning ML, if someone asks you that what is the preferred distribution of data, what do you expect, sir? Gaussian, sir, normal. This is what we prefer. Why, sir? Symmetry, sir. Left equal to right, sir. Sir, mean, median, and mode are also equal, sir. Okay. These statistical parameters make our calculations effective, efficient. rather than working on biased data. For example, if I would say you do have a distribution like this, or if you are having a distribution like this is biased, I hope you know about outliers. So because of the outliers, this become biased. So we expect normal. That is why we transform our data into normal distribution. We try to transform the data into normal distribution. Okay, got it. So some of the concepts I'm keeping for the rest of the class. All right, we'll see. We'll see. Hmm. Now I have some coding questions also for you to do. Before that, let me show you my Kaggle notebook. I'm sharing this Kaggle notebook for you to practice right now. I expect everyone should have a Kaggle account. Here is a Kaggle notebook I'm sharing. Writing, okay. Writing, I guess my wordings are clear. And if you have any doubt, then you can ask to me. Training, testing, validation means okay, ma'am. I will let you know. All right, and y equal to mx plus c ppt. Okay, we'll make the ppt also for you. Not an issue. Okay, any other question, please? You are open to ask the question if you have any. Meanwhile, I've shared the. Okay, here it is. My Kaggle notebook. This is my Kaggle notebook. You can click. You can open the notebook on the side. Please open the notebook on the side. You see the codes. One question came related to training, testing, and validation. Let me answer that question. Everyone, please listen carefully what this training, testing, validation means. Obviously, we are going to train the data for a model, 80% as I told, as per the splitting. Validation data is the data that is 10% will be used during training only. During training only, we need to validate our model that how the performance is going on, because during training only we will understand that in first iteration accuracy is 80% for the training, 85% for the validation. In the second iteration, 86% for the training, 83% for the validation. In the third iteration, 90% for the training, 80% for the validation. What it means? It means that after every iteration, training scores are getting increased, validation scores are getting decreased. That means model is subject to overfitting. But but listen, if the accuracy is 80%, 85%, 86%, 84%, 90%, 89%, this is not an overfitting seen during training. This is not overfitting seen during training. However, we expect once the model got trained, then we test the model. In that case, if you are getting 88 or 89% accuracy, then this is not overfitting. You got it correct, because your validation score is 89 and you are achieving in testing also. All right, got it. Understood. This makes sense. Fine. Now, I do have some codes to work upon. This is my Kaggle account. Everyone should make a Kaggle account. Or if you are working on Jupyter Notebook or any other platforms, that is fine, not an issue. Okay. But if you are having Kaggle, you can use the GPUs also. Here I am available with the GPUs. Okay. In session options, if I click on accelerator, I am available with the GPU. Okay. I request everyone that to create a Kaggle account, because this is a data science repository, like or big uh, platform where data sets are available, codes are available. You can also design everything. And free GPU for a week you are going to get for 30 hours quota when you register by your mobile number. Then you are going to get the GPU. So not only create account, register with your mobile number, then you are going to get the accelerator. Understood. Right now for this code I don't require any accelerators. These are the basic codes which I have done for you. Okay. So like what came into my mind is the one which I did for loss, huh? Regression and classification. Subject to that, I did some code. NumPy is a library for it's numerical Python for linear algebra. We do use NumPy. Okay, we use NumPy. Okay, I think code should be visible properly. Okay, I think it's there. You can see the code now. Is it visible to you properly? Yes. All right. It's because you have also opened in your side. Okay. So NumPy imported random seed 42. That means once you run the code multiple times, we don't want output to change. Like this is reproducibility. Random seed 42. It is for reproducibility. Code reproducibility. Okay. I do have the comments also. Random seed for reproducing results. Comments also. This code without comment. Okay. And I kept the comments also for you to remember that what we did. Okay. Fine. So this is for reproducing the results. Random seed. I made a data 103. That means 3 column, 100 rows, and also theta. This is a parameter like weight and the bias. Now I told. So this is parameter theta. Random x values, random y values are being created. These are the predictions. What I need to do? Actual minus predicted or predicted minus actual, whatever you will say, you can to the square, to the power square, and calculate the mean. That will be the loss, and we are going to print the loss. Only the basic, which I told mathematically, here I am doing in the code wise numerically. Okay, here are the comments if you want to go through. So I do have the number of examples. That is my data set. Three column, 100 entries. I'm trying to define the coefficients. These are the coefficient values. These are the random values of x. These are the random values of y. Okay, and we are computing the predictions using estimated coefficients x into theta. Wx. That's why you predict wx. All right. If you want to incorporate a bias, so apart from theta, you can add one more parameter and add a bias. Not an issue. That can be added. So once you are having the predictions, actual is there. Prediction you did to the square, that will be the square error. Take the mean, that will be mean square error. That's what I've shown in the regression part. For classification, you are having the random values for class 0. Let's say binary classification. Random values for class 1. Total 200 values with two classes. Got it? Arrange them one above the other. Okay. Then use sigmoid to classify because this is binary classification. This is binary classification. Use sigmoid to classify. Okay, got it. Here is a formula. Cal- Calculate a parameter value theta. Keep the bias. So W is there, bias is there. You need to apply the sigmoid function, logit function. That is also called as logit function. Okay, and define the probabilities after applying sigmoid. Okay, based upon the probability, you will say You will say to which class a particular value belongs, either 0 or either 1. You calculate the probability. Here is the loss. Here is the loss formula which I have told, which I have explained you using that apple and the peach. Okay, so P log Q 1 minus P 1 minus Q. This is that only. This is P and Q only, written in format like cross and row. Got it. A very basic code, very primary code. At least you directly apply from sklearn import linear regression, from sklearn import logistic regression. But what is happening beside linear regression logistic? Some sort of mathematics, some sort of code. I explain it. Okay, fine. So like you run the code and results will be in front of. Got it. Okay. Regression error also, cross entropy loss also you get it. The formula which I explained are present in the coding part. Okay, then I do have few more things like if you are having a data set, if you are having a data set, I made it for petrol price, where date is there, month is there, day of the week is there, is weekend is there, region ID is there. Okay, so day Wednesday, sorry, day mapping like weekday is 0, weekend is 1, holidays 2. Mapping day type ID will be mapped in this way only. Okay, weekday 0, weekend 1, holiday 2. Day type ID. Here are the columns present in the data: diesel price, crude oil price, USD to INR, month, day, weekend, region ID, day type. This is how we are going to make a data set. We need to predict the petrol price. So, like if you are available with the data, if you are available with the data in pre-processing, you need to scale the data. As I told previously also, we never split and give it directly to the model. No, this is not the thing. First, you need to convert non-numerical into numerical. You need to scale your data also, because if you don't scale your data, there is a big concept of variance uh, and standard deviation present beside. Let me tell you clearly what is the issue. What is the issue? Just two more minutes give to me. Very important. Variance and standard deviation. Why we scale the data before putting it into the model? Why? If you don't scale the data, those features, those columns whose variance is high, their data point distribution is high, they will contribute high in the model development. And those features who are having less variance, they will be overshadowed by these features. That's the answer. So variance needs to be scaled for all features, mandatory. So that is why there are different kind of scaling techniques: standard scalar, min max scalar, robust scalar. There are so many techniques. Okay, here I have used standard scale. Scale your data, then give it to the model. Okay, don't give data to the model directly without scaling and it will do any nonsense. That will be a failed model. Alright, so that's what I have done here. I've used standard scaler here. Okay, these are my data values, the date, petrol price, everything has been there. I prepared. Alright, and I did the scaling part. Okay, got it. So, like a basic primary concept based sample coding so that you can run, you can understand from your side what is happening, and slowly I will raise the level, because I do have some questions from your side to perform. These are the questions which you need to perform over the coding. Got it? Fine. That's what I need to tell today. That's what I need to teach today. How you find it, please? That's what we do have for today's class. Okay, Mr. Anirudh. Okay. Okay, Mr. Vijay. Thank you. See, I will be like in this way to teach you. I'll try my efforts, give my efforts more for you to understand the very important concepts which are required in machine learning and data science and deep learning and all these. Okay, because apart from that, you don't understand, you don't catch the primary concept, it will be difficult for you to build up any kind of AI model, any AI architectures like this. Okay, so let me share the Kaggle or notebook. Fine, this is enough. All right. So, like, I request everyone